Okay, fifth video on elastic collisions in 2D. Here's a question, give it a go and then come back when you're ready for the answer. Right, let's start off by labeling up the diagram. It's pretty well labeled so far. The only thing we don't have a label for is the final velocity of A. So I'm going to call that W because V's already been taken. Now, if we do some resolving perpendicular to the line of centers, we know that the initial and final components are the same because velocity never changes perpendicular to the line of centers. Okay, it only changes parallel. So we can form the equation 2u sine 45 equals w sine 45. And we can cancel out the sine 45s. So in essence, 2u equals w. So we can now replace this w with 2u because we know w equals 2u. If we do the same for b, we get that 3u sine 30 is equal to v sine theta. That wasn't a very good theta, was it? And sine 30 is a half, so 3 over 2u equals v sine of theta. So these are two quite useful equations here and here. Now the next thing we can do is look parallel to the line of centers. And what we can do is we can condense this from a 2D problem into a 1D problem to make the maths easier. So if we redraw the balls, we're now going to consider them in one dimension. So the top velocities that I'm drawing on here are going to be the initial velocities, and the bottom ones are going to be the final ones. So this is A, which has mass 3m, and this is B, which has mass 2m. And the initial velocity of A is 2u cosine 45, which is just root 2u. Okay, so that is this part here, the parallel to the line of centers component of this part. And the initial velocity of B is 3u cosine 30, which is 3 over 2 root 3u. So they're the initial components taken by resolving these components here, okay, parallel to the line of centers. Now, if we look at the final velocities, we know the final velocity here is 2u cosine 45, okay, which is once again root 2u. It's just in the opposite direction this time to the initial velocity. And we do the same for B. This parallel component is v cosine of theta. Okay, so this one here is v cosine of theta, and that's acting in the opposite direction to its initial velocity. So this is a diagram we get in one dimension when we look at the collision, and we know that the coefficient of restitution is e, so that might come in handy. What we can do now is use the conservation of linear momentum to form an equation. So we know that the momentum before is the momentum after, so let's form the equation. 3 root 2 mu minus 3 root 3 mu equals minus 3 root 2 mu plus 2 mv cosine of theta. And the reason some of them are negative is because I'm taking the left as negative and the right as positive. So the velocity is acting to the left. These two end up negative in the equation. So if we add this 3 root 2 mu to both sides, we get 6 root 2 mu minus 3 root 3 mu equals 2 mv cosine theta. Now, first thing we can do is cancel out the m's because there's an m in every single term. So that's nice, that works out quite nicely. Right, and now we've cancelled out the m's, we can make v cosine theta the subject to the equation just by halving it. So v cosine theta equals 6 root 2u minus 3 root 3u all over 2. Now, why have I made v cosine theta the subject of the equation? Well, if we look back at the equations we developed at the start, we've got v sine theta in terms of u up here. Okay, I'm going to copy that back out. V sine theta is equal to is equal to 3 over 2u. So now I've got v cosine theta and v sine theta. I can use the equation that v equals the square root of v cosine theta squared plus v sine theta squared to work out v in terms of u. So it's equal to the square root of v cosine theta squared, which is 6 root 2u minus 3 root 3u over 2 squared plus 3 over 2u squared. That's the v sine theta. So that's that, and that's that. And that gives me v as 2.22589u. So v is 2.22589u, and there's not really any way to get that exact. I like to keep it in exact form if possible, but this question, the calculator spits out as a decimal, and that's all the exam would want. So that is v in terms of u, and if I were you, I'd round it to 2 or 3 significant figures, so I'm going to do it to 2, so that's equal to 2.2u. like so. So that is part AI. Now let's look at part AII. It wants us to find the value of theta. Well, that's quite straightforward now because we know the value of v. So if we go back up to these equations here, we know v sine theta is 3 over 2u, and we know v. So we can rearrange for theta to get theta equals the arc sine of 3 over 2u over v, like so. Now I'm going to bring that down with me. And plugging in v, we get theta equals the arc sine of 3 over 2u over 2.22589u. And obviously the u's are going to cancel because v is in terms of u. And when we put that in our calculator, we get that theta equals 42.3678 ... which is 42 degrees to the nearest degree. So that's theta. So for part B, we have to find the value of E. We know E is the speed of separation over the speed of approach. And the speed of separation is found by adding these two velocities because they're in opposite directions. So E equals V, which is 2.22589u, cosine theta, which is cosine 42, plus root 2u. So what I've just drawn here is the speed of separation. And that's divided by, that was not a very good line, that's divided by the speed of approach, which is root 2u, once again, plus 3 over 2 root 3 u. And the reason we add these is because these are once again moving in the opposite direction. And when we do that, we get 0.76235 ... which is 0.76 to two significant figures. You could give it to 3, but I've given it to 2.